Now let's learn the derangement, which is a very specific situation. That is, it's a permutation of certain number of elements such that no element is in its right position. Let us take an example of this. Suppose we have 4 letters and corresponding 4 envelopes. So this we have 4 letters and 4 envelopes. So assume that each of the envelope is marked off with the same number or same letter as that of the letter. So if we designate 4 letters as say A, B, C, D, then the 4 envelopes should also be marked with A, B, C and D. But now we want to find out how many such arrangements are there in which none of the letter goes into the envelope of its own letter. So therefore A should not go to the A and B should not go to B and so on. So there is a formula for total number of derangements which is given by dn. This is the symbol for derangements, that is given by n factorial into bracket 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial and so on up to minus 1 raised to n whole upon n factorial. So basically here we can see that wherever we have the factorial of even number in the denominator, the terms are positive. Wherever we have the factorial of odd number, we have the negative term. So that is taken care by this particular term, that is minus 1 raised to n, which decides the plus or minus sign. So therefore if we consider the example of 4 letters and 4 envelopes, that is here if n is nothing but 4, so therefore if we want to count how many derangements are there for 4 elements, it's nothing but d4, which is given by n factorial, which is 4 factorial into bracket 1 upon 2 factorial, which is 2, minus 1 upon 3 factorial plus 1 upon 4 factorial. So as n is 4, we will consider only up to this particular term. So evaluating further, we have 4 factorial nothing but 24 into bracket 1 upon 2 minus 1 upon 3 factorial is nothing but 1 upon 6 and plus 1 upon 4 factorial is nothing but 1 upon 24. So on simplifying this, the simplest way is rather than taking the LCM, we can directly expand the bracket and get 24 by 2 is 12 minus 4 plus 1. So that turns out to be 9. So there are 9 such arrangements in which none of the letter will go into its own envelope.